Hello everyone, July 21st. Tired. I'm very tired. But finally, the editing of the paper has come to a temporary end. I still need to do a proofread tomorrow. Hopefully it'll be fast, and I'll send it out to my advisor tomorrow. So he'll take a look. Yeah, initially this paper is for conference, but that's very interesting. Like he initially has something he want me to do, and I kind of don't want to do it. It's like, it's very complicated. I even wrote an email explaining why I don't want to do it, but I was very wise not to send that email because I thought I might as well finishing everything and then send it to him. So as I was doing the paper, writing more and more, and I was like, you know what? Maybe what he asked for is good. I should do it. Maybe. Who knows? So I did it. Took a lot of efforts, but did it. And the paper now blow up like to 18 pages. That's not a conference paper. That's like 12 pages too much for a conference paper. So maybe that one will go for a journal as well. Who knows? All right, let's take a look at today's stuff. Longest increasing subsequence. Oh, the problem. Given an integer array nums, return the number of longest increasing subsequence. Okay, longest increasing subsequence. That the sequence has to be strictly increasing. The number of longest increasing subsequence, the number, it's not the length of the longest increasing subsequence. How do you even find the longest increasing subsequence? I don't remember how to find longest. I might have to go back to that. But here, the longest increasing subsequence is 1, 3, 4, 7, around 3. I mean, it doesn't really matter, right? So what we need to do is just to find the longest increasing subsequence and then count how many there are. Well, given the number, the length is 2000, so it might be O(n) squared. I mean, that's what we want to do, O(n) squared. We can do O(n) squared, which is fine. O(n) squared is easy. Let's try O(n) squared to see if it passes. But is it O(n) squared? Is this problem solving O(n) squared? I don't remember. Dear me, why are you open at the bottom? Oh, because I have something open at the bottom. Alright. O(n) squared. Okay, we can try O(n) squared. O(n) squared, it shouldn't be too bad. It's just a dp problem, right? So I say dp equal to this, right? For any nums. So what we want to do is to find the longest, right? The longest. So we have the n, so we searched previously to find. So the dpi is the longest, dpi records the longest increasing subsequence, the length, right? Ending at I. So we're looking at n, so what we want to do is go backwards. So we can say current will equal to 1 because we can always record 1. Then we go previously. You know what? We do have to use this enumerate because I need to find previously. We can just say for I, for j, in range all the way to I, but not including I. Then we say if nums j is smaller than n, then current shall equal to maximum. Right, current and dp j plus 1. Yeah. So we go through all that and say dp.append current. And at the end, we're going to, we can count along the way. Now, just at the end we count. What do we count? We can do a counter. Right? Then we say counter dp dot most common. Yeah, what's most common? Most common return 2, so I need to return this count, right? I need to return the count. So most common, wait, hold on, most common, I need to put a value, 1, right? That's all I want. Most common 1, and then do 1. That should we return. Not sure if this is acceptable. This should be 5. Nums. Find number of LIS. Nope. I actually don't know. Counter dp dot most common 1. What is that? Oh, over 0 and 1. 0 and 1. Okay. That looks right. Oh, let's see. Let's see if it pass. Did it work for a single value? Not sure. It should. Will we time out? No! Ha! We got a wrong answer. Alright, now we're talking. Expected 3, I only get 2. What? That's bonkers. 1, 2, 3, 4, 7. Oh, yeah, that's not right. This is only, yeah, if we take a look at the DP is not right. DP, we have 5, right? This one is 5. Wait, hold on. It's not the most common. It's not the most common. Jeez, man. It's not. It's the longest. It's how many we have? 5. But this one will return 1, so it's wrong anyway. Okay, that's okay. That's fine. It's wrong anyway. Because we can do... I need to find a number of... So the DP condition is different. Is the number of longest that's ending at the current position. Because if I have 4, the longest is 3, right? I have 3, the longest is going to be 3. 5, the longest is here and here. Look, this is a 2. So yeah, it's going to be different. So dpi is equal to the length of LIS and a count, right? Count of LIS. So current should be 1 and 1 and 1. I have 1 count, right? So blah blah blah. If this and, right? Because we would do bigger. Oh yeah. Hold on. If dpj 0 plus 1 is equal to current, then current 1 plus equal 1, we find another one, right? We find another one. If dpj 0 plus 1 is larger than current, then current equal to dpj 0 plus 1 and a 1. Count as 1. So now what we need to do is we need to find the maximum. Yeah, we do have to find the maximum. So it's a max LIS equal to 0, right? And once we do this, we'll append and max LIS equal to maximum max LIS and a current 0. So once we're done, we need to return sum. No, dp dot count max LIS. I think I can do this. Zero. Nope. Well, of course, I can now count directly. 8. Does it have a key? Zero. Nope. Nope. Oh, okay, that's fine. That's fine. So for length and count in dp, if length equal to max this, then we do C, and then we sum this. Ew, that is very ugly. That is very ugly. Hold on. 1 1 2 1 3 1. As 3 is 3 1. There's 5. We have 4 because it can do 1 2 4 5. 1 2 3 5. So it's 4 2. And this is going to be 1 2 4 1 3 4. So is this, yeah? And then wait, hold on. There's 1 2 4 3 5 4. This is not right. This is not right. This 4 can do 1 2 4 and a 1 3 4, which means we go to 3, which is this. We have 1. Oh, it's not plus equal 1. It's a plus equal to dpj and 1. Well, first of all, this is dpj 1, right? Because you want to inherit whatever is there, right? Whatever is there. And then if this is the case, that's not 1 because you're doing dpj. So that's also dpj 1. That makes more sense. Okay. Yeah, the original solution was just so stupid. I don't know. I blame it. It's late. All right, let's see if this one passes. It does. It does. So, but I still wonder what is the best way to solve LIS. I have an idea actually. I think it can be solved using BIT. You know, we can use BIT to do LIS if you just want to do LIS. So what I want is we can query, right? Query the longest. Maybe BIT can do this. We not only do the longest, but we can also count. What do you mean count? From start to this, give me the maximum and give me I don't know, give me the maximum length. Right? That's basically what we want. We want a maximum length from something to something, right? And in addition to that, we also want the count, how many there are with this maximum length. I am not sure, but let's read the solution. 673. 600. DP contains two values. One is the max length of LIS so far, and the other is the total number of LISs that can reach such length ending at current index. Alright, what is the solution? DP O(n) squared, top down O(n) squared. What is this? No, actually, I'm more interested in this one. LIS. I think O(n) squared will work for this for sure. And I said it's one of my biggest challenges. Okay, so let's try this. Let's try this one more time. The length of the longest, I mean, I can always do O(n) squared, right? I can always O(n) square this thing. Actually, let me, can we reset? Yeah. So I can always O(n) squared, right? I say dp equals to this for I, and enumerate nums current equal 1 for j in range I if the nums j is smaller than n, current equal maximum current and dpj plus 1, and then dp.append current, and I'll return the maximum of dp. This one, right? Is this one pass? O(n) squared? Yep, O(n) squared pass. But look, I have a very, very good solution there. So what is that one? I've actually seen the pieces that this is a binary search. So it must be something related to binary search. Yes, you want to come up with a O(n) log n time. I don't remember. Honestly, I don't remember. From this to this. I mean, I can use BIT. Yeah, I can use BIT, but let's not use BIT for this one. We know we can do binary search on this. How? What is the insight of doing binary search? I remember is you create an array, separate array for binary search. I still don't remember, man. What is binary search on this one? Yeah, we don't have a sorted thing, so we will create that's what I remember. You will create a sorted array, but how do we create a sorted array? I don't have any clue. Man, this is tough for me. I've been solving this so many times. I still don't remember. I don't remember at all. What was the method for this one? Oh. I seem to remember. Once we have some value, right? Let's say I have some value and I know the current longest subarray is 4. And I know the current value is here, right? And then the next one coming in, I have all these values. Okay, let's say I have sorted, right? Now a new one comes in. If it's smaller, then I'll swap. We will swap. Yes, the idea is we want to create this longest strictly increasing subsequence. That's what we want to create, right? And each time, and then the way to make it the longest is for each value to be as small as possible. So if the current value is smaller than some of those, then I will just swap it in, right? So it can be smaller. If it's not smaller, then we just add it to it. So in this case, we start with 10, right? 9 is smaller, so we swap out to 9. 2 is small, so we go to 2, right? Then we have 5. Then 3, swap. Then 7. Then 101. Then 18. So yeah, 2, 3, 7, 18. We have 4. Nice. Remember, I remembered it. I remember. So LIS equal to this. And then I'll binary search this. Binary search for n in nums. Okay. Index equal to bisect right ls and n. And if index is equal to 0, because what we want to do you want to bisect left or bisect right? Because you want a -1, right? So if index is 0, then you need to replace 0. Nah, I don't want to do that. What do you want to do? If it's smaller, that will be 0. I want to do this. I want to put nums1, 0 in it. Okay? And then we say for n in nums 1 to the end. Then we can do this, right? Then we say if index is equal to 0, then lis index equal to n. Elif index is smaller than len lis, right? Then lis, oh, no, because it has to be it's in between these two, right? So this is smaller, so I shall replace the one pointing by, because that's small, this is big. No, my bad, I think this should be left. then we can just say if it's smaller, then we'll replace it. Yes, if it's equal, we can handle this. If it's not equal, we can handle it as well. Then else list.append n. Now return length of list. This is right. This is right. Yep. To practice this, you need to practice this. I wonder if we can solve this problem. Can we solve today's challenge using this method? I don't know. But we can think. What if I, at each position, we can do multiple different, right? We can do multiple different. And then at the end, you know what? I am intrigued. I want to try. What do you think? Well, here's what I think. If I go 1, 3, 5, 4, we don't replace it. We do replace it. We'll replace it, but we record it. This is we have 2 values here, right? And then 7. So this answer is 2. Interesting. That's very interesting. How about this one? We have 2, and then 2. So this will be 1, right? And then we do 2 again, 2 again, 2 again, 2 again. All right, we need to test one more. Let's try this one. See if it works. Okay, so we'll go 1, 2, 4. Right, now into 3. So this one will be 2. And 5. Right, and then 4. 4, this will be replaced to 4. So this will we have 2. Then 7. Then 2. Oh no, yeah, it doesn't work. Yeah, because something at the end, you can like replace the ones in the front, and that doesn't really make any sense. No. So the ones that does make sense, like I think this 4 and 3, this makes sense. Right? And then we have 5. And now we have 4. 5, 4. But we cannot multiply. Yeah, I guess it is just DP then. That's fine. Okay, let's hit one more. And ready to call it a day. Let's hit one more. Number of senior citizens. You are given a 0 indexed array details. Passenger compressed into a string of length 15. The first 10 characters consist of the phone number. The next is the gender. The following indicate the age. The last determine the seat allotted to the person. The number of passengers who are strictly more than 60 years old. You wanna? Okay, that's fine. I might want to do another one. This one is a little bit too this simple. For D in details, we want to say int something, right? D something strictly larger than 60, and now we sum this down return. What is this? So first 10 characters consist of the phone number. The next character 11. So 2, so 12 to 14. Yeah, is this one right? No, it's not right. What? I mean, I count wrong. Oh, yeah. This is 12 should be 11. My bad. Okay, so, this is alright. Let's try the next one. Sum in matrix. You're given a 0 indexed 2D integer array. Initially, your score is 0. Perform the following operations until the matrix becomes empty. From each row, select the largest number, remove it. In the case of a tie, it does not matter which number is chosen. Identify the highest number amongst all those removed in step 1. Add that number to your score. Return the final score. Okay, so let's see. We have 7, 2, 1, 6, 4, 2, 6, 5, 3, 3, 2, 1. All right, step number 1. We'll remove the largest value, so it's 7, 6, 6, 3. I have the highest number removed. That's 7. So this one will give us 7. Okay, now next step, that'll be 2, 4, 5, 2. This one will be 5. The last one will be 3. So 15. Okay, so basically we just sort everything from high to low, and then sort high to low for each row, and then get each one. We also sort high to low. No, we just get it max. We don't have to sort. Okay, so this one is has enough stimulation for today. Yeah, because I want to finish reading the book, so I think it's good. It's good. Yeah, I'll stop right here. Okay, and then we say return for j in range len nums 0. Okay. And we need to do the maximum of something for I in range. Let's do L, M, and N. It's like for decency. Mn equal to nums. Right, and then for I in range nums, we'll get nums ij. Okay, now we get the maximum of this, and we find the sum of this. Okay, let's see if this one's right. Looks to be right. Okay, that should be it. All right, I'll stop here. I'll do this tomorrow. All right, I'll see you guys tomorrow. Adios.